All right, so now what we're going to do is we're going to actually take an angle. We're going to sketch that angle on our unit circle, and we're going to find the coordinates of the terminal side. So let's start with a negative 45-degree angle. So we know we start by putting the vertex at the origin, and the x-axis is the initial side that represents 0 degrees. And since we've got a negative angle, we know we're going clockwise. So negative 45 degrees would be halfway between 0 and negative 90 degrees. So that's going to get us right here. And as you're sketching these, if you try to make it look approximately like it's in the middle, if it's closer to one side or the other, you should probably make it closer to one side or the other. That's probably a bad drawing there. It looks like that's a little bit closer to the middle. Okay. So now what we're going to use is the special right triangles in order to find our exact value. In order to get the exact value, you need to use the special right triangles. Now the special right triangles, what we talked about on the other side. Okay. This is where we had the 30, 60, 90 degree triangle, where across from 30 was a half. This was 1/2. Across from 60 was square root of 3 over 2. Okay. And on a 45, 45, 90 degree triangle, okay, across from 45 was square root of 2 over 2. Okay. So recall that information is what I said that you really, really, really need to remember. Okay. So on here, we've got this is negative 45 degrees, and what we're going to do is we're going to draw our triangle, and again, out of habit, I draw my triangle up or down to the x-axis, but you don't have to. You can go left to right to the y-axis. So that's going to make this a 45, 45, 90 degree triangle, because from here to here is negative 45 degrees. Okay? So this is a 45, 45, 90 degree triangle. We know that the hypotenuse on the unit circle is 1. So now, remember from the other side, a 45, 45, 90 across from 45, 45, 90 degree angle is square root of 2 over 2. So that makes this side of the triangle square root of 2 over 2, and this side square root of 2 over 2. Okay. So now we're looking for the coordinates of this point. So what are the coordinates of that point? Our final coordinates, the x value of this point would be how much do we need to move over? Well, that would be this side of the triangle. That's square root of 2 over 2. How much do we need to move down? That would be your y value. That is also square root of 2 over 2. So the coordinates of this point is square root of 2 over 2 for the x, square root of 2 over 2 for the y. Okay? So let's try another one. Let's do positive 150 degrees. So again, we put the center of the circle at the origin. This is our initial side at 0 degrees, but this time we're going positive. So this is going to be positive 9 degrees, and this is positive 180 degrees. So 150 degrees is just slightly short from 180. Okay? So this is our angle here, and this is the point we're trying to find. We're trying to find out where our terminal side intersects the unit circle. So I'm going to draw my triangle straight down. So now I need to know how many degrees are these angles inside this triangle. Well, if this is 150 degrees right here, well, how many degrees am I short of 180? Well, this angle right there would be 30 degrees, which then would make this angle here 60 degrees and that 90. Okay. So again, from the other side of the notes here, 30, 60, 90. Across from 30 was a half. Across from 60 was square root of 3 over 2. Okay. So again, let me draw that here. This is 30, 60, 90. This is a half. This is square root of 3 over 2. So here's my 30 degree angle. So that means this side of the triangle has to be a half. This side is across from 60. That's got to be square root of 3 over 2. So now we can write the coordinates of this point. The x value would be how much you need to move over. That would be the bottom side of this triangle. That is square root of 3 over 2. Okay. And then the y-coordinate of this point would be positive 1/2. Okay? So that's the coordinates. Now, on both of these here, I made a slight mistake. These are the values, but I did not account for positive or negative values. So on this one, number 1, when you move across, this is positive x, but when you go down, this is negative y. Okay? So this is positive square root of 2 over 2, and this is negative square root of 2 over 2. Okay? On this one, our x is negative, and our y, because we're moving up, is positive. So this is negative square root of 2 over 2 and positive 1/2 as our values there. Okay? So if you're using special right triangles, that's what we're going to do. On number 3 here, we want to find the approximate value. And you'll see why we have to do approximate here in a second. For the approximate value here, if we sketched our angle, okay, we're going to go 40 degrees. Okay? So our initial side here is 40 degrees. This is 40 degrees. But we have a slight problem here, because if we draw our triangle here, this is 40, 90, 50. And 40, 90, 50 is not a special right triangle. So in this case, we need to use something else, because we can't use 30, 60, 90, can't use 45, 45, 90. So we have to use something else. Well, what else do we know? We know from the section above here, if I move up a little bit, that the x-coordinate was represented by the cosine and the y-coordinate was represented by the sine. Okay? So if we come back down here, we know that for the coordinates of the point, the cosine of theta is our x and the sine of theta is our y. Okay? So our angle measurement here is 40 degrees. So if we did the cosine of 40 degrees, we get our x value. If you do the sine of 40 degrees, you'll get your y value. So on our calculator, okay, on the calculator, first of all, and let me get rid of this information over here. On your calculator, first thing we're going to have to do is check your mode. So on the mode, let's make sure our calculator is set to degrees. So on the third one down, select degrees, okay? And then, because all our angles are going to be in degrees, then all you need to do is type cosine of 40, and you will find out that the cosine is approximately 0.766. And then we could do the sine of 40. And if we do the sine of 40, you'll see that that is approximately 0.643. Okay? So that gets you the x and y values, x and y values of this particular point. This is approximately 0.766. This is approximately 0.643.